Hi, good morning. Today we have come to the series on integration by parts. First, I will prove to you the formula. Now, the formula for integration by parts is derived from the product rule. So let's differentiate uv by dx. So what do you get over here? You have v prime u plus u prime v. Now let's say we want to make this as the subject of the formula. So you have u prime v will be equals to duv by dx minus v prime u. Now let's integrate both sides by dx. You will have u prime v dx. This is the derivative of uv. Now you are doing its integral. It's just like inverse function. Alright. This is the differential, you do the integration of it, so you will get back uv minus integral of v prime u dx. Now this is the formula, but how to make use of this? Now let me just show you. Now this is differential of u. Now what you do is first you do the integral of this. So you integrate u prime, you integrate with respect to x, you get u. So the first one you integrate. Now, then let me use a different color. This one you copy. Alright? You copy. Then followed by negative and the integration sign. Now, what you integrate here, later on you copy over here. Then what you copy over here, you differentiate it. Maybe I just write it this way. Differentiate it. Alright. Now, then the last part, of course, you try to integrate this. Now, the question is we cannot always use integration by parts. Alright. The last part, when you come to this form, you must be able to do this. There's no point you come to here and then you get stuck. So you can't carry on. The next thing to take note is which one should you choose to integrate and which one should you choose to differentiate. Now I will illustrate this by doing a few examples. Let us start with A. Now you are asked to integrate this. So which function? There's two functions here, e to the power of x and tangent inverse x. So which one you choose to differentiate and which one you choose to integrate? Now you look at this tangent inverse e to the power of x. Now do we really know how to integrate tangent inverse x? Don't talk about e to the power of x. Is it easy to integrate? Not all functions are integratable. Alright. So you look at it, tangent inverse x is not in the formula sheet. We can differentiate tangent inverse x, but there's no formula for you to integrate tangent inverse x. But can we differentiate this? Yes, it's very easy to differentiate. And this is to integrate e to the power x. Yes, we can integrate e to the power x. So let's try to do it this way. Now, so this one we choose to integrate, and this one we choose to differentiate. equals. Now, so the first one, you integrate. All right, you integrate this function, then followed by you copy. Then followed by a negative sign. Integrate. Now what you have integrated, you copy it over here. Alright, so I copy it. Then I differentiate it. This one, what I have copied, I differentiate. So I differentiate this. What do I get when I differentiate this? Now I get e to the power x over 1 plus e to the power of x squared. So this should be 2x. Maybe I just write 2x. All right. So this should be 2x. It's a mess. Never mind. You know it's 2x, huh? Okay. So we just copy this. Now, let's simplify this. So the top is e to the power 2x plus e to the power of 2x dx. Now, you look at this, what do you get if you differentiate 1 plus e to the power of 2x? You get 2 e to the power of 2x. So if we rewrite the top as this, then we must times a half here. Now the top is now the differential, or the numerator is now the differential of the denominator. So we can use the ln integral. I mean, this is nothing but, okay, so this is nothing but ln of the denominator, because the numerator is the differential of the denominator. Now you want to make sure that what is inside the ln is always positive. So we do a mod here and we plus c. Alright, that's the end of this question. Now let's move on to part 2. Part 2, there's only one function. So can we integrate ln x? It's not in the formula sheet. So it's not easy, or perhaps it's impossible to integrate ln x, because not all functions can be integratable, or I would say maybe it's not easy. So how to integrate ln x? So what we can do is we write this as 1 plus ln x. Then you have two functions here. One is a 1, one is a constant, the other one is a ln x. Now can we integrate x? Yes. Now can we integrate 1? Yes. We get x. Can we differentiate ln x? Yes, we get 1 over x. So ultimately they can cancel. So you can see that actually the function reduces to something that is simpler. So what we choose over here is we integrate this, and this one we choose to differentiate. So we integrate the 1, you get x, then you copy, followed by minus the integration sign. What you have integrated, you copy, then you differentiate this function. Now what do you get over here? You get 1. So integrate 1 is x. Then you plus a constant. Okay, we have come to part C. In part C, you are asked to integrate x times ln x. You find that it's quite hard to integrate ln x. Of course, we did over here, but it's quite hard to integrate. So I will choose to differentiate this, because this is pretty easy to integrate. An integrate of x, you get x squared over 2. Differentiate this, you get 1 over x. When you multiply that together, the x squared can cancel off with the x. So let's integrate this. I got x squared over 2. Then I copy the other one, minus the integral. This one you copy over here and you differentiate. This is 1 over x dx. So here you got x squared over 2 ln x. Now this one you are left with x over 2 because the square you can cancel off with the x here, this x. So you got x over 2. And when you integrate x over 2, you got x squared over 4. Of course, don't forget your c as well. Now how about the last one? The last one, you can see that e to the power x is, when you differentiate or when you integrate e to the power x, it will give you e to the power of x. Whereas for cos x, you differentiate cos x, you get minus sine x. And then you differentiate one more time, you go back to cos x. Now, it doesn't matter which one you choose over here, because you'll find that the thing alternate, right? Because of the cos, this e to the power x will remain unchanged, because you differentiate, you will keep on getting e to the power, you integrate also e to the power x. Whereas this one, if you differentiate, it will become cos to minus sine. Then you differentiate minus sine, you get back to minus cos. So it's like, you know, it's have this feeling as like it's a cycle. Okay. So now let me do this question and you will understand what I mean. So I choose to integrate this and differentiate this. But in this case, it doesn't matter. You can choose to integrate this and differentiate this as well. You will get both, you will get the same answers. So maybe I take out the 2 first. Okay. Now I integrate this, I get e to the power x, and this thing remains. Alright, then followed by negative integral of e to the power, this one I just copy the integral, and I differentiate cos x. I differentiate cos x, I get minus sine x. So I got sine x here, and this one, because this is minus, so this become plus, and you have a dx here. Close bracket. Now let's do it one more time. I choose to integrate this and differentiate this. So I got e to the power x, this term I just copy down, plus. Now integrate e to the power x is e to the power x. Then this term I copy. Then minus. Now, minus the integral sign, then this one I copy. And I differentiate sine x. I differentiate sine x, I get cos x. Okay, you realize these two terms is the same, it's a like term. I multiply the 2 in, I got 2 e to the power x cos x plus 2 e to the power of x sine x minus 2 e to the power of x cos x dx. Okay, and I bring this over there, or over to the left hand side. What will I get? I will get 2 integral of 2 e to the power of x cos x dx, and that is equals to 2 e to the power x cos x plus 2 e to the power of x sine x. Okay, so I need to just divide by 2. So integral of 2 e to the power x cos x, I will get e to the power x cos x plus e to the power of x sine x. and of course plus C. Now just now when I mentioned cyclic, you see, look at this term, it comes back to the same term again. Alright, so you can bring it across to the other side. That's what I mean by, cyclic. For that, we come to the end of this video. I hope you have learned something from this video and continue watching. Thank you so much and have a nice day. Bye.